Okay, so today's video is going to be on trigonometry and how to use the sine, cosine and tangent ratio functions to find the lengths of sides or the size of an angle for a right angle triangle. So first of all, we'll start off by defining what a right angle triangle is. A right angle triangle is any triangle so long as it has a right angle in it. So they can come in any other size or orientation. For example, a triangle like this is also a right angle triangle. Now that we understand what a right angle triangle is, it's extremely important to understand how to define our adjacent, hypotenuse and opposite sides. The hypotenuse is the easiest side to define, and I'll explain this by using the right angle as a key indicator to identifying our hypotenuse. The hypotenuse is always directly opposite the right angle. It is also the largest side of a right angle triangle. So for this triangle, opposite the right angle and the longest side is this side here. Let's try for this triangle here. The side opposite the right angle is this side here. This is also the longest side of this right angle triangle. So we can call this H for hypotenuse. Don't get confused with the opposite side. This is what we'll do next. The opposite side is opposite to the angle that we are looking for. The opposite side to our unknown angle is this side here. We'll define that as O. For this triangle, if we have this angle, X, our opposite side will be this side here. We'll define that as O. Note that if we had swapped this angle for this angle here, our opposite would now be here. For our adjacent, it is simply the last side that we haven't defined yet, which is this side here. We'll define that as A. And we'll define this one as A. So it is really important to get practice on understanding and defining your right angle triangles. SOHCAHTOA is a helpful acronym. We'll start with SO. SO is sine x equals to opposite over hypotenuse. CA is cos x, which is equal to adjacent over hypotenuse. TOA is tan x, which is equal to opposite over adjacent. So these are what you would call trigonometric ratios, and we'll use them to find unknown values for our angles or any of our sides. We'll go through an example and that will help you understand things a lot better. So for this example, we have a right angle triangle with an unknown angle. We're also given lengths of the two sides, 8 and 10. Going back to the information that we learned earlier, we need to identify what these sides are. The side opposite our unknown angle is the opposite. Our longest side and also opposite the right angle is our hypotenuse, and the final side is the adjacent. Okay, now that I have information on the opposite and the hypotenuse, I'm going to check which one of my trigonometric functions to use. I can't use the tan since I need information on the opposite and the adjacent. I can't use the cos because I need the adjacent and the hypotenuse, but I can use sine since I have the opposite and the hypotenuse. So we can write this as sine theta is equal to the opposite, which is 8, over the hypotenuse, which is 10. Sine theta now becomes equal to 0.8. Now, to find theta, we just need to do the inverse of sine, which will give us our final answer. If we do shift sine 0.8, we should get 53.13. 53.13. So our angle theta is equal to 53.13 degrees. Okay, so for this example, we're given a right angle triangle and two pieces of known information, our angle and the length of one of the sides. Now this question is asking to find the length of y. Let's do what we did in the last question and identify each of our sides. So the side opposite our angle is our opposite. The side opposite the right angle and also the longest side is the hypotenuse. The last side, which is y, is the adjacent. So we're looking for the adjacent side. So let's write down the pieces of information we have, which is h, the hypotenuse, theta, the angle, and we're trying to look for the adjacent. So we need to find a trigonometric ratio that involves all three of these. They all contain theta. Now we just need to look for the one that contains the hypotenuse and the adjacent. Can't use sine. Can we use cos? Yes. Can we use tan? No, since this is looking for the opposite and the adjacent. Let's substitute all of these values into this ratio and now solve. Cos of our angle 42 is equal to our adjacent over our hypotenuse, which is 12. Rearranging this, we get 12 times cos of 42, and this will give us the value for our adjacent side. Putting this in the calculator, 12 times cos of 42 gives us 8.9177. So our adjacent is 8.9177. Therefore, y is equal to 8.9177. So just as a quick summary, just remembering how to identify our side. The side opposite our angle is our opposite. The longest side is the hypotenuse, and this is the adjacent. If we're looking at this triangle now, the opposite is now this side here. The hypotenuse is always the same, keep that in mind, and the adjacent now becomes this one. Notice how these two have swapped because our angles are relative. Our sine theta is equal to opposite over hypotenuse. Our cos theta is equal to our adjacent over hypotenuse, and our tan theta is equal to our opposite over adjacent. So that's what you've learnt today. Please comment on what other topics you would like to see videos on.